NFTs have taken the world by storm over the past few years. With the rise of major collections like CryptoPunks and Bored Ape Yacht Club soaring to sky-high valuations, this has created a massive opportunity for everyday people with a little bit of coding knowledge, some creative inspiration, and a dash of hustle and self-promotion to launch highly successful projects. Like the 12-year-old boy who made $400,000 with his NFT collection on his summer holiday, or the 12-year-old girl who raked in nearly $4 million with her collection. And what's crazy about NFTs is now you can code them to where they will pay you passive income in the form of royalties while you sleep. And that's exactly what I'm going to create in this video today as a blockchain developer myself who works this technology on a daily basis. So if you're new around here, hey, I'm Gregory, and on this channel I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to become a blockchain master step-by-step start to finish, break into the blockchain industry, increase your salary well past 100K, I can show you how to do that over at dappuniversity.com/bootcamp. All right, so let's get into this. Let's talk about how to create a passive income NFT that pays you royalties anytime the NFT is bought or sold. So let's see the problem that this solves. So most time when people create NFTs, they create an NFT drop where the NFTs are created from scratch. And basically what you do is you go to a website where they're issuing the NFTs and everybody lines up with their wallet and then purchases the NFTs to the contract, and the developer gets that money. But there's a problem with this, okay? So basically, the only time that you as the developer of this project can really make money is when people purchase the NFTs. Like you get the ether that they pay into the contract in order to get the NFTs in return. Or, you could hold back a handful of the NFTs for yourself and have to sell them later. And there's no really good way to get paid on an ongoing basis anytime other people buy or sell the NFTs on an open exchange like OpenSea, for example. But now, thanks to the ERC 2981 NFT royalty standard, you as a developer can get paid anytime someone buys or sells your NFT on a marketplace like OpenSea. So let's see how that works. So basically, whenever you're going to have an NFT contract here that's going to get listed on a market contract like OpenSea. Okay, whenever someone purchases this NFT, let's say they're buying it for 1 Ether, and the seller lists it for, let's just say 1 Ether, and they make that exchange, you, the creator, are going to get kicked off a royalty that's hard-coded into your NFT, let's say of 0.01 ETH, and you're going to do that anytime someone buys or sells on this exchange. And that's going to be available with this ERC 2981 NFT standard. And what's even better is you can get this basically for free with hardly any effort from the Open Zeppelin contracts. So now what I'm going to do is show you how to create your own NFT project quickly with a library like Open Zeppelin that implements this standard so that you can plug it in and start making that passive income. All right, so let's go ahead and start coding out the project. So I'll put a link to this repository down in the description below. What you're going to want to do is go to your terminal and type git clone, all right, and then paste in that URL. I've already done that, okay, so you're going to see an error here, but you'll see the cloning message like successfully, done on your terminal. And then once you have done that, you're going to do cd eip 2981 example. And once we're inside here, we're going to install all of our dependencies for this project. Now, the good news is you really only need one global dependency installed in order to follow along with this tutorial. So that's Node.js. This is basically just an environment that lets you run JavaScript on your computer and pull in JavaScript packages like, Hardhat, which we'll use for the smart contract development, Ethers.js for, using JavaScript, and also with the blockchain, and also Open Zeppelin for those smart contracts. Okay. So you can see if you have Node already installed by going to your terminal and typing node-v. All right. If you do not have it, you can install it with the link that's going to be in your README file here. So make sure you've got that. And then once you are sure that you have it, go inside of your directory here and do npm install. That's going to pull down all the other dependencies that we need, like Hardhat and these other things that I just previously mentioned. All right, so I've already installed my packages, so I see this message here, but you'll probably have to wait just a few seconds, maybe 60 seconds for your packages to download, and then you'll see a success message at the end. Now, I'm going to go ahead and open my code in a text editor. Okay, I'm using Sublime Text. You can use whatever text editor you'd like. And here I can see all of the files that are included in the project in this directory here. So in the contracts directory, I've got some smart contracts already created. One for an NFT, all right, and one for a marketplace that we can actually showcase this example. All right, so you can see those are the 2 contracts in my diagram. This NFT that will wire up to use the royalty standard, and then a marketplace to demonstrate that royalties are paid out. Okay, and additionally, we have some tests inside of here that show you how to check for this behavior, and I'll work through those in this example. All right, so now I've cleared out all the code from the NFT contracts that I can actually walk you through the code and show you how it works. Okay, this won't be exactly step-by-step coding, but we'll get to the important parts quickly because the whole point here is to be able to bootstrap this and use the library to get it running quickly. All right, so what I'm going to do is start with step one, which is to import the OpenZeppelin libraries. All right, again, I was trying to show you that OpenZeppelin is a library where you can import some of this functionality basically for free. All right, so it shows you that you need to import these different token standards, the ERC 2981 standard for NFT royalties, along with a few other packages. So I'm going to go ahead and just do that like this. So this gets the royalty contract and then all the other dependencies that we need for our NFT, like the ERC 721 enumerable, URI storage, the ownable contract, and then the counters contract as well. Okay, and then once we import those, we need to actually inherit from all of these different imports inside of our smart contract like this. So we're going to say contract NFT is one we're creating, but how you do inheritance and solidity is you just say is, and you can pass in each contract that you want to inherit from. Okay, you can see all of these correspond to a file that we just imported here. All right, so now we need to set up our contract with some state variables to make these other libraries work as well. So we're going to start off with this ERC 721 URI storage and enumerable. Okay, so this is going to essentially give us some URLs, that work with, give us some special string behavior. So what we want to do is basically import this into our contract using strings for UINT 256. That's going to allow us to do some special things in Solidity that doesn't work out of the box so that we can support these two libraries. Okay, I wouldn't obsess about what you need this for. Just know that you need it in order to make that work. Same thing for the counter. All right, so we can use counter for counters.counter. All right, you can see that's coming from here. All right, and then we're also going to use this here to count the token IDs. All right, that's going to work with our other ERC 721 library. All right, we're also going to set up a state variable for the string metadata URI like this. All right. And then finally, we need a place to store the artist address and then the royalty fee for this ERC 721 royalty contract. So we're going to do that like this. We're going to store a state variable that's the address of the artist or the creator in this case, and then a UINT 96 for the royalty fee. We're just going to use a smaller unsigned integer here because we don't need a massive one in order to store that fee. Next, we're going to create a constructor function. Okay, this is the function that's run once and only once whenever the contract is deployed or put onto the blockchain. Okay. And really what that's going to do is just allow us to pass in some information whenever we create the contract, like the name, the symbol. All right, so every NFT has a name, it has a symbol so that it can be identified on marketplaces. We just pass that right along to the ERC 721 contract, which we inherited from here. Okay, and you'll be able to read that on your wallet or on the OpenSea marketplace, for example. Next, we want the metadata URI, all right, which we are saving here. Okay, but we don't hard code it into the contract. We actually pass it in whenever we create it. Same thing for the artist. The artist address will get saved here, but we're going to pass it in at the time of creation. And same thing for the royalty fee. We declare it here, but we set it inside the constructor. All right, so next we're going to use the mint function. Okay, so going back to our diagram, this is our NFT royalty structure, but let's look at the diagram for our NFT drop, because this is going to work like many of the other NFT drops where you can receive money whenever people create your NFTs from scratch at the time of, doing them on your website like this. Okay, so we're going to use a mint function for this. People are going to mint the NFTs from scratch. So let's implement that into our contract here. All right. We get this function mint. It's public. Anyone can call it. Okay. And so what we're going to do is basically, call safe mint, which comes from the OpenZeppelin libraries. Okay. And then we're going to set the token URI. All right. Which comes from the URI storage right here. And we should pass in the token ID that's created. All right. And then we're going to basically, store the actual string for the URI here. But here is the really important part that you need inside your contract if you're doing royalties. Okay, this set token royalty function. It's going to take a token ID, the artist who is going to receive the royalties, and the royalty fee. All right. Again, we pass those into the constructor function. We save them here as state variables. They'll never change. But then whenever someone mints it, then we'll know what the royalty fee is for that specific NFT always forever on chain. All right. And you can see documentation about this inside of the OpenZeppelin, documentation here. All right. You can see the set token royalty function right here, which we are using right here. And so the whole point is you need to create mint function. You can do whatever you want to inside that mint function. You can implement whatever kind of crazy behavior that you want to. But if you want your NFT to support royalties, you must include this function anytime that new NFT is created. It's not a royalty for the entire collection. It's a royalty for each individual NFT on each case-by-case basis. All right, and that's basically the default behavior if you want to set royalties that are set inside the constructor that will never change. But what if you want to create a contract where you could potentially update the royalty fee at some point in time? Well, you can do that like this. You can add a new function called set royalty fee that takes a new parameter and saves it to the state variable just like this. Now, this could potentially introduce some trust issues with your project, so you only want to do this if it actually makes sense, okay? Otherwise, you can just leave this function out and you can not hard code, but you can set the royalty fee once and only once in the constructor if you want to do that instead, all right? So finally, what we're going to do here is add some overrides, okay, that you need to do because you're inheriting from all this stuff. For example, like your token is going to have a burn function, okay, that's included in some of these libraries, particularly the ERC721, ERC721 URI storage, and ERC721 royalty. So if you don't include these in your contract, the compiler is going to yell at you. So what you're going to do is basically just override these, and then you're going to do set token royalty whenever you burn it. Again, that's this set token royalty function that we did here. You need to call it inside the burn mechanism as well, okay? So same thing on the before token transfer callback, basically. You're going to do the same thing. You're just going to override it and call the exact logic inside of here. You don't need to change anything. You don't need to set any royalties. You just need to have this in here so Solidity doesn't scream at you or the compiler doesn't scream at you whenever you are trying to create your contracts. Same thing for the token URI, okay? You'll want to just override that and then do super token URI, nothing fancy inside of here. And then finally, the supports interface, okay? You're going to do that down here. Basically, supports interface, interface ID. You're not going to add anything to this. You're just going to super the function in the parent contracts here, here, and here. All right, so now what we're going to do is show you the tests for this so that you can observe that the behavior that we just coded out actually works, okay? So over here, I'm going to open up a file tree. I'm going to go to the test directory and find this nft.js. I'm going to open it in a second tab so you can see it beside my production code here with the smart contract. So basically what we're going to do is, I'm not going to code this out. I'm just going to leave it as is, but I'll explain it, okay? So basically, we just have a test here that describes the NFT. We set the name, the symbol, the metadata URL, and the royalty fee of just 500. This is actually 5%. Again, this is in a percentage value. It's not like an ether value or something like that. You don't want to use decimal places in your smart contract. So this normally would look like, this 5.00%. Sorry, like this. But you don't use decimals, so you do that. All right. And we essentially set up some accounts here, deploy our artist and minter, and then we create a variable for the NFT contract itself. We pull these addresses, the signers, out of our Ethers wallet, and then we deploy the NFT contract with all the variables that we created here, the name, symbol, metadata URL, and the royalty fee. So we basically just describe the deployment, just make sure the name, symbol, royalty fee, and artist are set properly. These are pretty straightforward, okay? And then we check the minting and royalty info behavior. So in this side that's before each, we basically just call the mint function and wait for it to finish, and then we check the results after. So the first thing is we check to set that the royalty info was set properly. We check that the cost is 1 ether, and then we check the royalty info and make sure that it expects to be 0.05 ETH, which is of course 5% of 1 ether, and that the math actually checks out on that. We also just make sure that once it mints, that the total supply was increased by 1, namely that only one NFT was created after the mint function was called, and that the owner of this new NFT, all right, is equal to the minter's address, okay? So the first ID is just going to be 0 in this case. So we can run those tests from our terminal like this. We can do npx hardhat test, but I don't want to run all the tests, okay, because I have multiple tests in that directory. So I'm just going to say test, which is the directory name where my tests live. And if I hit tab, you can see there's 2 files in here. There's marketplace and nft.js. I'm going to say nft.js, hit enter, and that's only going to run the test for the NFT test and not both of the contracts, which we haven't really set up just yet. Okay, so I can see those are passing. All right, so now the NFT contract is done. Let's look at the marketplace contract. Okay, so going back to this, we need to basically have two smart contracts that talk to one another, because the only way that the NFT royalty feature is actually going to work is if a marketplace picks up on that and then actually pays out the royalty whenever the transaction between the buyer and the seller takes place, and then that gets paid to the artists themselves. So what we're going to do is go to our marketplace.sol file here. Again, we got a couple of functions inside of here. I'm going to clear this out and we'll implement it sort of piece by piece. All right, so now I've cleared out the code here with a few exceptions. All right, I have imported the NFT contract. That's literally just the file right here that we just finished. All right, and then I have the skeleton for the marketplace contract like this. Just use the contract keyword and we give it our name, marketplace, okay? So the first thing that we want to do is create a place to store the address for this NFT and then save it so that we can reference it in the code. All right, so I'm just going to say NFT public NFT. That's just going to let us save the smart contract itself so we can call its functions inside of here. But then we need to actually pass in the address for it once it's deployed. All right, so we'll use the constructor function for that. Again, this is the function that's run once and only once whenever we put the contract in the blockchain. So we say constructor, and then we pass in the NFT address, and that's going to create a new sort of instance of the NFT and then save it as a state variable right here so that we can call the NFT functions whenever we buy and sell the NFTs themselves, okay? So next, I'm going to create a couple mappings so that we can, save some information on chain. Basically, I'm going to have a mapping to see if an NFT is listed. So basically, it's going to be the ID of the NFT, and it's going to return true or false on whether or not the NFT is listed for sale. One for the cost of the NFT, so a mapping of the NFT the NFT ID, and then a number of the cost in Ether, and then also a mapping of the lister. So this is going to be the NFT ID and the address of the person who has listed it for sale. Okay. So the first thing we do is create a list function. All right. So like this, basically function list, it's going to take the token ID of the NFT we're trying to buy or sell, or really sell in this case, and then the cost that you're listing it for sale. Okay, we want to make sure that it's not listed yet, so we add this require statement. And then we transfer the NFT out of the lister's wallet into this smart contract, okay? And basically, we're just going to call the transfer from function that comes on the ERC 721 standard, give it the sender's address, who's listing it, and then transfer to this marketplace, and then also the token ID. Now, this is an example NFT marketplace. Again, this is not a fully fledged marketplace like OpenSea. This is just to demonstrate the royalty feature. So you would want to have some type of like delist function for sure. Ideally, it wouldn't actually be taking it out of the person's wallet just yet. Like you would only do that at the time of the sale. This is just an example to show you how it works. Okay. So anyways, we store the lister here. All right. We store the listing status and then also the cost in our mappings that we just created. So finally, we need a buy function so we can observe the royalty behavior in action. All right. And we create a buy function like this. Basically, we just call it buy. We pass in the token ID that we want to buy. We make it payable so that somebody can send in Ether with this transaction whenever they're paying for it. We just add some requirements to make sure that the NFT is actually listed and that the amount that they are sending in is actually enough money, that it's greater than or equal to the cost of the NFT that's listed. Okay. So we delist the NFT at the time of purchase, and then we get the royalty info. So this is sort of the heart and soul of the royalty implementation. We read the royalty info from the NFT. All right. We pass in the token ID, the cost. Again, that's a function that comes from this Open Zeppelin library. You can get the royalty info. We did set token royalty whenever we coded the NFT, but now we're getting the royalty info whenever we are, essentially doing the purchase. So it takes the token ID and then the sale price, and it will return, the artist who's going to get the royalty payment, and then also the fee. It's going to calculate the percentage. We put in a 5% fee. So if they're buying this for 1 Ether, this is going to return, 0.05 Ether, and we're going to send that to artists. So that's what we do right here. Basically, we just do artist call. Okay, this is a method that's going to let us send any message that we want to an address. In this case, it's going to contain value, which is just a way of transferring Ether. Some people do transfer. I've moved more towards using call to send Ether around, but if you don't know what this does, basically it's just sending cryptocurrency, essentially the fee, directly to the artist. And that's, this step right here in the process. Okay. Then finally, we're going to pay the lister. All right. So basically we just send Ether to the lister. We pass in the message value that's getting paid for the NFT, but we take out the fee. All right. Again, they're just the fees coming out of the sale price. The lister gets slightly less than that, and it goes to the creator. And then finally, we transfer the ownership of the NFT from this smart contract that currently holds it to the buyer themselves. All right, finally for the marketplace test, we're going to do something very similar to the NFT test. Basically, we're just going to store all the deployment variables at the top, like the name of the NFT, the symbol, the metadata URL, the royalty fee, and then the cost. Okay, we set up the accounts here for the NFT and the marketplace because for this example to work successfully, we need to deploy both contracts. Okay, so you've got the royalty fees here, and then you got the cost here, and then we deploy each. So in the before each function, we set up the accounts. All right, we get the NFT just like we did in the last test, but now we get the marketplace, which we just finished coding out. So we deploy the NFT first. We need the address for that in order to deploy the marketplace. So here we get the contract factory for the marketplace, and then we deploy it, and then we pass in the NFT address from the previous deployment here into the constructor function so that we can actually interact with it. Okay, and then we call a mint function to create one NFT. All right, and then we approve the NFT from the minter's wallet, and then the minter lists the NFT on the marketplace with the list function. Okay, we pass in the NFT ID and the cost to list it for. So we create a basic test that just checks for a successful deployment. That's pretty straightforward. We just check that it actually has the NFT address saved, and then we actually test for the buying and royalty behavior. So inside this before each function, we basically do a purchase, or well, really so basically we listed here, but now we're going to buy. So we check a couple things. We check the minter balance before, the buyer balance before, the artist balance before, just to make sure everybody's balances are correct after we can check those. And then we actually trigger the buy right here for the ID 0 and then the cost. All right. So we check that it sets the royalty fee, sends it to the artist. All right. We expect the artist's new Ether balance to have this 5% royalty here. Basically, we're just adding 0.05 ETH to their current balance, which in hard hat is 10,000 Ether, I believe, by default. Okay. So we just checked that 0.05 Ether was added to that. All right. And then we check that it updates the original minter's balance. It's hard to know exactly what it's going to be. So we just check that the result for their balance is greater than the minter balance before. Okay. And then finally, the buyer's balance, we just check that some amount was debited from their wallet, basically that the result is less than the buyer balance. And then we update the ownership of the NFT, that now the new owner of the NFT should be the buyer's address. Okay. So now we can check for that in our terminal. We can do npx hard hat test. And then instead of running the NFT, we just do marketplace. All right. And boom, it passes. Okay, so we can also run all the tests just to make sure that everything still works. We can just do npx hard hat test. It will run everything inside this test directory here, the nft.js file and the marketplace.js file. And after we do that, we see that everything is green. All right, so that's an overview of how to create your own passive income NFT that will pay you royalties while you sleep. So if you like this video, as always, smash that like button down below for the YouTube algorithm. Subscribe to this channel if you haven't already. That really helps these videos out so the more people learn about blockchain. And if you want to take your skills to the next level so you can start creating your own NFT projects, whether it's for yourself or other people, I can show you how to do that and break into the blockchain industry, increase your salary well past 100K over at dappuniversity.com/bootcamp. You really don't have to be an expert to get started today. I've helped people with zero coding experience become real world blockchain developers in a matter of months. So that's all I've got. Until next time, thanks for watching Dapp University.